Hello, everybody. Thank you for joining our webinar today. My name is Chris Rickey. I'm a solutions engineer here at CoreOS. And as a solutions engineer at CoreOS, I have the opportunity to work with a lot of different organizations, different sizes, different industries. And one of the common topics that often comes up when I'm working with a lot of my clients is around continuous integration, CI/CD, and Kubernetes. And so in this webinar, what I want to do is go through some common patterns that I've seen working with customers, and from both an integration perspective and how Jenkins and Kubernetes works together, as well as some common patterns around some deployment models for how you actually deliver your applications and deploy your applications into a Kubernetes cluster. Before we get into it, just a little housekeeping. We do have a chat available in the Bright Talk session here, so if you have any questions, we'll be monitoring the chat, and I'll take a look at them at the end and I'll try to answer all of your questions you may have. And if you have any questions following the session, if you want to get a hold of me, I'm easy to reach on LinkedIn. You can get me on email. I have a Twitter handle. I honestly am not that active on Twitter, but if you tweet me, then I'll definitely respond. So with that said, in terms of our agenda and what I wanted to talk about, I'm going to give a brief overview of Jenkins and Kubernetes, and chances are you guys are probably already familiar with these tools, otherwise you wouldn't be joining this session. But I do want to get into why they work really well together, and as I mentioned, some of the common patterns that we see. And I'll wrap things up with a demonstration of a few common deployment scenarios, and the predominant ones that we work with customers on today are usually blue-green deployments and canary deployments. And so I'll get into what those are and what the differences are and kind of how they are set up within Kubernetes. So what is Jenkins? Jenkins is an open source automation server, and it's typically used for automating all of the steps and tasks that are required to get your application changes deployed, built, tested, and deployed out to an environment. And I think the reason why Jenkins has become so popular is because of its extensive plugin library, where it makes it really easy to integrate with all of the other tools in your tool chain, and it essentially becomes like an orchestrator. And I'll get into this in a little more detail, but one of those plugins happens to be a plugin for Kubernetes, which makes it really easy to, from a deployment perspective, for Jenkins to deploy your changes into a Kubernetes cluster. Jenkins is by no means the only CI, CD platform out there. There's lots of them, and just so you know, I mean, they all work pretty similarly from a Kubernetes perspective in how you could actually deploy your changes. The reason why we're focusing on Jenkins today is, again, oftentimes it's what we see, pretty commonly out there in the field and in a lot of different enterprises. So that's Jenkins in a nutshell. Kubernetes is an analogy that we like to use when we talk about Kubernetes.
Chris?
It's like a, yes.
This is Amanda. Can you toggle to your screen share part? Because right now it's just showing your slides.
You're not seeing my slides?
No, you got to hit the screen share. It's not letting me do that on the back.
Sorry about that. Getting used to the new Bright Talk. I apologize, folks. Let me get to my screen here. Thanks, Amanda. Can you see it now?
Yes, now I can see it. That's great.
All right, great. So as I was saying, for Kubernetes, an analogy that we like to use with Kubernetes is to think of it as a smart thermostat for your home, where the smart thermostat helps maintain the ideal state of your house, the temperature, and you open a window and the house cools down, it'll kick on your heat, or if it's hot outside, it'll kick on the AC. Well, Kubernetes is sort of similar, behaves in a similar way for your actual applications and your infrastructure that's running your applications. And so what I can do with Kubernetes is define what the ideal state is for the application that I'm running, and it'll ensure that I always have that defined number of replicas for my application running. If a replica of my application crashes, it'll spin it back up. If I want to define rules in terms of when an application scales up or scales down, I can do that as well within the cluster or within Kubernetes. It also makes your applications portable. So it unlocks you from the underlying infrastructure, whether you're running on a cloud platform like AWS or Azure, or whether you're running workloads on premise. The way you deploy and run your applications in Kubernetes is consistent and it's the same. So a lot of organizations look to leverage Kubernetes as a way to provide hybrid experience for their cloud. The other thing that is important about Kubernetes is that it makes your deployments consistent. So what we often find when we're working with customers who haven't yet containerized or haven't yet moved their workloads into an orchestration platform like Kubernetes is every application tends to be a little unique. It's like a snowflake. They all have their own custom scripts, their own processes in terms of configuring the underlying infrastructure, and that results in a lot of technical debt. It's essentially a lot of scripts and code and things that have to be maintained over time. So Kubernetes simplifies that pretty significantly and allows all of your applications that are running in the cluster to deploy in a very similar and consistent way. So that's really important. And again, if you're not familiar with sort of the history of Kubernetes, it's an open source project that Google contributed back in 2014, and it's gained a tremendous amount of momentum in the industry, and you're seeing it being adopted by a lot of the major cloud platforms. A lot of different vendors are starting to invest in Kubernetes. And so that's Kubernetes. Tectonic is the CoreOS enterprise distribution of Kubernetes. So Kubernetes being an open source project, there are a lot of challenges that we see customers face as they try to deploy Kubernetes in a production, enterprise-ready way. And so that's why we have Tectonic. And when Tectonic, we focus on three key pillars. The first being around enterprise security, so making sure that it adheres to all of your corporate standards. For instance, integrating with your identity management systems in the back end, role-based access controls, TLS certificates, and encrypted traffic throughout the cluster. The other thing is around monitoring and chargeback, and really understanding the health of the cluster itself. As you start rolling this stuff into production and you've got mission-critical workloads running, you want to make sure that your cluster is always healthy, and if there is a problem, you're made aware very quickly. And so that's something that we focus on very heavily with Tectonic. And then the third bit here is all around really lowering the cost of ownership for running Kubernetes in your at scale, and that covers things like automated operations. So Kubernetes is an incredibly fast-moving project. It's in fact, it's one of the fastest-moving projects in the open source world, on GitHub today. And so there's new releases coming out very frequently, new features and patches and security fixes that are being released regularly. And so it's really important for organizations that are adopting Kubernetes to stay up to date. And that can be quite a challenge when you're running, pure open source upstream Kubernetes. And what we provide with Tectonic is the ability to, with a click of a button, update your entire cluster to the latest stack. And Tectonic typically lags upstream Kubernetes by a matter of a couple of weeks. And we also make sure that not just the cluster is up to date, but your entire operating system. These are just some of the key capabilities that we would touch on in terms of security. So again, integrating with your backend identity providers, layering on open cloud services. So if you have applications, and actually I'll show this a little bit in the demo, where your applications you want to also be able to monitor the health and status of, you could leverage services like our Prometheus open cloud service that runs in the cluster that you could then use to instrument your application and get a better sense for the health of and status of your workload that you've deployed. And then, as I mentioned, the ability to monitor, pre-configured monitoring of the cluster. So we've taken all of the expertise that we have running production Kubernetes with our large enterprise customers, and we've provided a set of pre-configured alerts that will notify you. We also have customers that are, when they're running on different clouds, they want to get a better sense for their cloud spend. And we offer capabilities to understand how much all of these resources that you're running in a cluster are actually costing you. And then, of course, the ability to, with a click of a button, update the entire stack, not just Kubernetes, but all of the things that we've added on top of it, as well as the underlying operating system. And we run across a variety of platforms, whether you're on AWS, bare metal, Azure, or VMware. So that's Tectonic and kind of what we do above and beyond Kubernetes. But why do we want to run Kubernetes and Jenkins together? So I mentioned before that a lot of customers that are deploying applications in a more traditional way have accumulated a lot of technical debt. And this is typically in the form of things like a lot of custom configuration management to configure the underlying infrastructure, and then custom deployment processes to deploy to whatever the target is, whatever your application server is, your web server, et cetera. But with containerizing your applications and deploying to something like Kubernetes, everything becomes much more consistent, and you no longer have to manage all this custom code just to deploy your applications. So that is a significant win for a lot of organizations, especially to have a large number of applications that they're deploying, or if you're deploying like a microservices-oriented application where you have lots of different services that have to be deployed, you want to make sure they're all done in a very consistent way. The other big benefit that we see of running Jenkins and Kubernetes together is around resource utilization. So in many cases, especially in bigger enterprises, they have lots of build servers. And those build servers tend to be underutilized quite a bit. They become pets. So where essentially you're patching these things and you're keeping them up to date, but they're not very elastic. And again, it's become expensive to maintain a large build farm. And typically there's teams of people who are maintaining these things. And so what's really cool about running Kubernetes and Jenkins together is it will give you an elastic build farm where your Jenkins slaves actually become pods that run inside the cluster. And so your build farm becomes elastic. And every build it basically spins up a new instance of of a build server that is from a known good configuration. So you don't have to worry about things like configuration drift, for example. So that's a big win. I'll show that in the demonstration and kind of how that works. And then the other thing, and this is really a benefit of Kubernetes, is that a lot of organizations are interested in adopting these more advanced deployment models. I mentioned it earlier, like blue-green deployments or canary deployments. Well, these are pretty hard and challenging to automate in a traditional sense without something like Kubernetes. And so Kubernetes provides a lot of primitives that I'll get into that make it easy to set up these types of environments. And then, of course, from a Jenkins perspective, Kubernetes is that target where we're deploying our applications to, and Jenkins can help actually orchestrate how we do things like the blue-green and orchestrate the deployment to the different environments. In terms of integration patterns, we see a couple of different trends, and again, it depends on where organizations are in their journey and their maturity. So one common pattern that we've seen is customers, they're already using Jenkins, they already have their existing build farm, and they're not quite ready to move into that elastic build model that I talked about. And so what they want to do is understand how they can simply integrate Jenkins and Kubernetes together so that Kubernetes becomes a deployment target. And that usually involves setting up a service account, that inside of Kubernetes that that when you do a build, it can leverage that service account to authenticate against the Kubernetes server to do things like your deployments and updates, etc. The next pattern is where the Jenkins master is still external to Kubernetes, but you leverage the Kubernetes plugin for Jenkins to create that elastic build farm. And so I'll show that in the demo. And then the third model is very similar, but it's where the actual master, the Kubernetes master, is hosted in the cluster, in the Kubernetes cluster as well. One of the reasons why, so when you're running an external master, you still have the challenge of distributing the service account credentials for the master to integrate with in order, the Jenkins master to use in order to create the and deploy the elastic, Jenkins slaves, the pods. When you're running a hosted master inside the cluster, then it can just leverage the internal service accounts and the benefits. So basically, when a deployment is run inside of Kubernetes, there's a default service account that's automatically attached to the pod. And so it makes it a lot easier to manage your service accounts in that case when everything's hosted inside of the cluster. You don't have to distribute them to the external servers. So those are the integration patterns from a Jenkins Kubernetes perspective. The next thing I want to get into is a demonstration of how we do some more advanced deployment scenarios. And the first one that I'm going to talk about is blue-green deployment. Now, if you're not all that familiar with Kubernetes and the underlying primitives, I want to, it's important to understand that Kubernetes is a bit like an onion. There's lots of different layers that are required to, before a container can actually be exposed to an end user. And it's important to understand these things because these are constructs that are used to create these blue-green deployment patterns as well as a canary that I'll get into. So what we're going to leverage in order to do a blue-green deployment into Kubernetes is that, if we start at the bottom here, our application is going to be deployed as a deployment, and we're actually going to have two instances of that application running. And so we have a deployment that we're going to call blue and a deployment that we call green. And so these are two different independent instances that we've had deployed, that we'll deploy for this container. And then each instance of that application is going to be exposed as a service. And essentially what a service does is it selects the pods that will then be exposed through an endpoint. And then the last bit here is at the top is our ingress rule. And so what an ingress is a rule that allows us to specify a route externally into that service that's surfacing that instance of our application. And so in this case, from a blue-green perspective, what we typically have is our ingress rule that's defined for our production endpoint. So in this case, it's helloworld.example.com. This is the ingress rule that all of our production traffic is going through. And then we also have a staging ingress that we use to test new versions of our application before we route production traffic to that new version. So, and then basically what happens is we have a blue deployment and we have a green deployment, and we switch the traffic between those deployments. So when and I'll get into this in the demo, but these are essentially the constructs that are leveraged in order to set up a blue-green deployment scenario inside of Kubernetes. So let's walk through this in a little more detail. So inside of my Tectonic Kubernetes cluster here, I have a namespace called blue-green that I have those two deployments in. So I have my blue deployment and I have my green deployment. And you can see they're actually running different versions here. But they each have 3 pods that are running. And so this is my deployment. And then I also have a service for each of those deployments. I have my blue service and my green service. Now, as I mentioned, an ingress rule is what's required to route traffic from the outside world into our cluster. And so I have an ingress rule here that is providing the route for my production traffic, simple web app. And this is, as you can see currently, pointing to my blue deployment. So all of my production traffic is going to my blue deployment. I also have a staging ingress that I'm going to use to test the new version as I deploy it. And right now, this is also pointing to blue, so they're running the same version. And I can actually look at my application that's running here right now. So this is my application that's running on staging, and you can see on my production here, it's running the same version. So what I want to do is make a change to this application and show you what that lifecycle looks like. So I have this simple application that's running inside, or that I have hosted inside of my GitHub repository. I'm going to make a basic change here. And I'm going to commit that. And inside of, so I'm going to flip over to Jenkins, and this is actually running inside of my cluster. Actually, if I go to my deployments, you can see in my default namespace, I have a Jenkins deployment running. Just a little bit of background, the way I got Jenkins installed into this cluster is using Helm. There's lots of different ways that you can install Jenkins into Kubernetes, but Helm is a really simple way. With a single command, it spun up the Jenkins master into my cluster, and then it became a very simple configuration, which I'll circle back to at the end to actually configure it with my with the right service accounts and things. So if I go back to Jenkins, I have this pipeline that I've defined for my simple web app. And this pipeline, this is really basic. In most cases, you're probably going to have additional stages where you do more verification and testing and things before you roll it out. But basically what this is doing is it's going to build a new version of the container image, and it's going to push it into my image repository, which in this case is Quay.io. And then it's going to deploy it to my staging environment, or by staging, it's basically the deployment, whether it's blue or green, that's not currently serving production traffic. So I'll show you that. But then once it's deployed to staging, I can verify it. And if everything looks good, I'll choose to roll it out to production. So let me go ahead and kick off a build right now. That should pick up that change that I made. So what this is going to do, we can look at the logs. This is going to spin up that Elastic Jenkins slave for me in my cluster. So if I go back to my Tectonic console here, you can see it actually just popped it up. I've got a Jenkins slave now that's running in my cluster. This is now running the build. We can follow along. It's going to check out the Git repository, and it's going to run the Docker, build based on the Docker file that I have in my repository, and it'll push it into my staging environment. So if so this is running, this is going to be build version 23 actually. If I go to my services, or my ingress actually, my blue-green namespace, what we should see is my staging environment. It just jumped up to version 23. So right now it looks like my staging environment should be running the latest version. And what I've done is I've just basically put a input in here to where it's halting the deployment until I choose to approve or reject this version. So let's look at our staging environment now. If I do a refresh, you can see now it's got the latest version of my application. But if I go to my production environment, it's still running the original version. So I've got now two versions of my application running in Kubernetes, but only one, only the old version right now is receiving traffic from production. So that all looks good. I can go back to my project here, and proceed. And that will now go ahead and roll out the update to my production environment. And basically what this is doing is it's flipping the service that my ingress is using. So before, when we look at this, it was pointing to the blue deployment, and now it's pointing to the green deployment. So let's go back to our production environment now that that's completed, and it's now running the latest version as well. So that's a quick overview of the blue-green deployment pattern. The next one that I want to talk about is the canary deployment, which is it's set up. It uses a lot of the same primitives that I mentioned in terms of using deployments, services, and ingresses. But the difference between a canary and a blue-green deployment is that in a canary deployment, you actually have two versions of your application that are receiving production traffic. But the canary, which is the latest version that you've deployed, is only receiving a small subset of that traffic. So there's a couple of different ways that we can orchestrate canary releases. What I'm going to show you is based on what we provide, what's provided out of the box with Kubernetes and like an Nginx ingress controller. In this case, we're using the Tectonic ingress, which is based on Nginx, and it also uses the same sort of ingress rule. But we're starting to see other tools out there like Istio, for example, service meshes, that allow you to do more fine-grained routing. So they provide their own ingress rules where you can define thresholds and percentages, essentially, of traffic that you want to route to one version or the other. In this case, the way we're doing it is a real simple scenario where we have our canary deployment for our new version. We've got our production deployment for what's considered our production workloads. And we manipulate the number of replicas for each of those deployments. And through the ingress rule, it's basically load balancing requests across those different, both of those deployments. So here I've got my production deployment, my canary deployment. I've got a single service in this case that's selecting pods from both of those, and my ingress rule is going to load balance the traffic across. So let me show you how that's set up, and then we'll walk through a demo. So in this case, I'm going to flip over to my monitoring namespace. And what I've also done with this particular scenario is I've instrumented my application with the Prometheus Open Cloud service that's running inside of my Tectonic cluster. And the reason why I do that is so I can verify that the health of my canary is good before I choose to roll it out. And so I'll show you what that looks like. But you can see within my monitoring demo namespace, I've got those two deployments that I mentioned. I've got a canary deployment and a production deployment. They're both running the same version 8 in this case. My canary deployment only has one pod, but my production deployment has 2 pods. So, and then if I go to my service, I have a Hello World service here, which is selecting all 3 of those pods. You can see it's selecting the 1 canary and the 2 production. So in this case, about 33% of my traffic is going to hit the canary. And I actually have, this application is a very simple API that I've been kind of pegging in the background. It's just spitting out this hello world here. So I've got 4 instances where I'm doing these curl loops just hitting the service. And what I want to do is make an update to this application, to my API. So let's do that. So I've got another Git repository here with this API that I'm going to make an update to. And we'll call this Hello World Updated. Submit my changes. And then I have a separate build project for this application where I'm going to kick off a new build. And in a similar way, a similar pipeline that I showed for the blue-green deployment, it's going to build the new version of the image. It's going to push it to my Query repository. It's going to deploy to my canary release. But in this case, when I deploy to canary, there's going to be real traffic that's hitting it. And then it's going to give me the opportunity to verify that canary before I choose to scale that version out to the rest of my production users. So this is really beneficial because it helps accelerate the rate of change, but minimize the impact in the event that there's a problem with that new version, right? If there's a problem with that new version, you've only isolated it to a small subset of your user community. In this case, I'm doing like 33% of my traffic, but in the real world, you'd have a much smaller percentage of traffic that's hitting that canary. So this is currently building. The other thing that I want to point out that I mentioned is Prometheus. So if I go back to my cluster here in Tectonic, you can see I have an instance of the Prometheus Open Cloud service running in my cluster. And this allows me or my application teams to instrument their applications with Prometheus so they can get better insight into the health and what's going on. So this is the instance of Prometheus that we have that we're using to instrument or to monitor our application. If I go to the targets, you can see that it's selecting those 3 replicas, one of them being the canary. I can look at the graph here. There's different metrics. So if we want to look at request count, for instance, you can see that the request count, it just keeps spiking because I've been pegging this thing over and over again for quite a while. And then we've also configured an alert. And so this alert is checking the status of, or the response time of that API. And what it's doing is it's checking that the overall response time, the average response time of this API is less than a second. And if it's more than a second, then it'll create an alert. So let's look at our API now. You can see, you can actually see that some of the canary, the canary is getting hit every few requests. So that's good. And what I've done with this actual version is introduced a sleep so that basically it's going to trigger this alert for me so you can see how what that looks like. And you'll notice every time it hits a canary, it kind of pauses for a second there. If I refresh my alerts here, you'll notice it indeed did pick up that there's now an alert for this application. That's because it's my response time for my canary is more than 1 second. And actually I can drill in and I can play with the PromQL here to get better insight into the metrics. So you'll notice this big spike. This is the canary that received the new version of the application. But the line across the bottom are our production instances that are still responding really quickly. So that's obviously a problem. We don't want to roll this version out to our users or to all of our users. So what I'm going to do is roll this thing back. And if you, I'm just going to pull these things up side by side so you can see in my in Jenkins, I'll go ahead and abort this deployment. And now all of a sudden, all of my requests are going to start returning the old version again, the healthy fast responding version. So that's good. Next, what I'll do is just fix my bug and then roll out another deployment and ensure that our application is just performing well. So the way I basically have a hard-coded sleep in here that I'm going to comment out. I'll add a comment fixing performance issue. I can kick off a new deployment. Obviously, from a Jenkins perspective, you could have it automatically build with every commit. In this case, I'm just triggering it manually. But so now that's going to go off and build again the new version, deploy the canary, and we'll be able to verify that we don't have any more alerts, and then I can roll it out to production so that all of my traffic receives the latest version. Let me take a pause here to see if there are any questions. Okay, so this question, how do you define how much RAM and CPU limits to set for Jenkins build, slave, agent, and executor? So that's a good question. Now, if you're using something like the Helm chart for Jenkins, actually, let me pull that up. These are things that I believe you can set in when you install Jenkins into the cluster. So what's really cool about Helm is it's essentially a template. It templatizes all of your deployments, and so there's a Helm chart that's been created to deploy Jenkins, and we can set with some either a variables file or from or through a command line flag when you do the deployment. You can specify the CPU and memory utilization for, in this case, the master, and then I believe the same for your agent. So they're separate parameters for the master as well as the agent. Okay, let's go back to our screen share. So we can see that my canary is now has been deployed again, and it's actually responding much quicker. So that should be a good sign. If I go back to Prometheus, let's just do a refresh, and so there's no alerts with this latest version, which is good. So now what I'll do is just approve our rollout to production. And we start to see all of our traffic now is returning the updated version. Okay, so that's how we do some of these advanced deployment scenarios with Kubernetes and Jenkins. The last thing I want to cover is just more from a configuration perspective. When we install the Jenkins plugin into the Kubernetes plugin into Jenkins, excuse me, we need to first go ahead and configure it. So if you go to configure system, it'll automatically inherit, when you're using Helm anyways, the URLs for the load balancer that Jenkins is being hosted on. But then we go down to the important bit here is in this cloud section. And so one of the things that you need to do is create a service or bind credentials to a service account. And if you're using something like Tectonic or a cluster that is using RBAC, or role-based access control, the first thing you'll need to do is configure that service account with the appropriate RBAC rules so that it can interact with the actual Kubernetes cluster. And so I've already configured it, and so when I test connection here, it's successful. But what that looks like, if I go into my Tectonic console here, and I go to my role bindings, if I go to default, excuse me, if I go to service accounts, I believe, yeah, so I've got a default service account here, and then in my role bindings, I have a Jenkins role binding, which is basically binding that default service account to, I'm using an admin role. It doesn't necessarily have to be as open as an admin role, but what you need to be, what you need to think about is what type of actions are your builds going to be performing when when interacting with a cluster. So if in some cases, so I've worked with some customers where they're actually creating new namespaces and creating deployments and services. Everything's basically spun up from scratch with every deployment, and so the service account has to have the access to be able to create a namespace, for instance, and be able to deploy into that namespace. So those are the things you need to think about. One of the nice things about Tectonic is that we give you a GUI here where you can create those roles as well as bind those roles to your service accounts. So here you can see, in this case, it's an edit role. It's got a lot of different access, rules and things that you can create, but it's really simple to go in and configure. The other thing from a configuration perspective that I want to point out is the pod template. So what the pod template does is it allows you to define the containers that are going to be included in that Jenkins slave pod. And the reason why I need to think about that is if, in my case, for instance, I'm using kubectl to do my deployments into the cluster, I'm doing Docker builds. So I need to make sure that the Docker CLI and the Kubernetes, the kubectl CLI are available in, to my slave. So what I have is a Docker image that has been baked with those utilities in it. But you might have other tools that you need, like Maven, for instance. Maybe if you're doing different tests, you need to have a container with the appropriate testing tools in it. So the pod template allows you to define what those containers are, and then they can, and there's a way to set up inheritance of things so that they can inherit your environment variables, and inherit things like volume mounts if they need access to the file system where the pod is running, etc. So this is all documented on the Kubernetes plugin for Jenkins. If you go to the GitHub repository, it gives you a lot of examples on how you can configure your pod templates. I'm showing it to you in the UI here, which is how I've configured it. But you can also configure these pod templates directly in your Jenkins files, where you're defining your actual pipelines. The other thing I want to point out is I'm passing in some environment variables. So in order for my build to publish the new version of the image into my Quay repository, it needs credentials in order to authenticate. So I've put these credentials in as environment variables. Another approach that you can take is you can actually leverage Kubernetes secrets, and the plugin supports leveraging those secrets that then get mounted to the pods, and you can leverage it in that way. So it might be a little bit more secure than what I have here. But again, just to show you that there's different options, and there are reasons why you might want to pass in other environment variables as well that could be useful. And then the other thing, last thing that I'll point out here are my volume mounts. So I have volume mounts that are allowing, for my Docker CLI. So as I mentioned, the container that I'm using runs the Docker CLI. So I'm mounting, because I'm running on, obviously in Kubernetes, my host, the node that is running all of my containers, has Docker on it. So I'm just simply mounting to this Docker sock so that the container that is doing the build can actually run Docker commands as well. And then very similarly, mounting the kube directory, which is what enables kubectl to basically inherit from the node the kube config so that it can interact with the Kubernetes cluster. All right, so that concludes what I wanted to show from a demo perspective. So I'm going to flip back and see if there are any other questions. Okay, so could you please compare the Tectonic API admin functions with the default Kubernetes dashboard? So this is more of a Tectonic specific question, but one of the things that's unique about the Tectonic console is that it is secure by default. So essentially you can, from a functional perspective, you can create your deployments and services and ingresses and persistent volumes and resource quotas, et cetera, all through the Tectonic console. But the big difference and the big benefit is that it's secure by default and allows you to integrate it with your backend LDAP from an authentication perspective. And then, of course, I showed you the role-based access control. So that's a really nice benefit for customers that are running this stuff in production, because when it comes to configuring security, yes, you can use upstream RBAC and manage all of the YAML and configuration files yourself, but it can become pretty error-prone, and you don't really want to make those sorts of mistakes from a security perspective. What is the minimum version of CoreOS in Kubernetes to use Helm? That's a good question. I don't think that there is a dependency on the version of Kubernetes or CoreOS. So basically, we are always running the latest version, of upstream Kubernetes, and so for instance, the version of Kubernetes that I'm running within Tectonic right now is 1.7.5, and we've got 1.7.9 coming out in a couple of weeks. Helm always works with the latest versions of Kubernetes, so it's typically not something you have to worry about. Please show and explain how Jenkins builds Docker image. Is it inside the same pod as DIND, or how is it configured? I'm not sure I fully understand the question in terms of is it inside the pod. Well, let me show you what my Docker file, my Jenkins file, looks like. So I'm going to flip back to the screen share here. So basically, if I go to my Jenkins file, this is for the application where I was doing the blue-green deployment. You'll see that I've just set defined some variables up top in terms of what's the name of the project and name of the ingress that I'm going to use, the staging ingress that I'm going to use, the Kubernetes namespace I'm deploying to, and I construct the image tag that I'm going to push to. And so what I'm doing is, the important part here is I'm adding the build number from Jenkins to my image tag. And then if I scroll down a little bit, this is where I am logging in to my Quay repository. And then I do my Docker build. So basically my Docker file is in the same image repository, or excuse me, is in the same GitHub repository. And so because I'm checking out my repository, the Docker file is going to be in the current directory. I can do Docker build -tag based on the tag that I've defined, and then I push it back up into my Quay repository. Hopefully that made sense. Let's jump back to, can you quickly show us the Jenkins file? Okay, so I just showed the, let me go back to, actually there's questions about how I do the proceed and abort within the Jenkins file, so I should show that. So the way that works is I basically have a user input that I've defined right here. And normally, actually, so what I want to point out, this particular Jenkins file isn't one that I would necessarily use for a production deployment for a scenario like this. And the reason why is I've defined a node block, and what a node block does is it basically spins up an instance of, it defines the instance of the Jenkins slave that it's going to run on. So in this case, it's when I have a node block, it spins up that Jenkins slave and it runs all of the stuff. But what I'm doing is I'm pausing the deployment here, waiting for user input. What I would normally do in production is actually take this outside of the node block, and once it succeeds, I would have a separate node block that would then go ahead and do my deployment out to production. So I just want to point that out. The reason why I have it set up this way is for demonstration purposes. It's just a little bit faster because it doesn't have to keep spinning up a separate agent. But the way it works is it's really right here. This is where we're doing the user input. I specify the message, and then if it either times out or if I hit abort, it falls into this this trap here, and it'll abort my my deployment or my build. Hopefully that makes sense. Let's go back. Okay. Just checking time. Okay, so could you explain a little bit more about your egress controller, proxy requesting in the Canary CD at the end? Yeah, so I touched on this a little bit, but what we're using for our ingress controller, so with Tectonic, we ship the Nginx ingress controller out of the box. And that's important because it's what's used to provide access to the actual Tectonic console. It's what is used to provide access into Prometheus. But we also allow customers to tap into that same ingress controller to expose their own applications, which is what I was doing with my blue-green deployment. Now, the Nginx ingress controller works really well for a lot of use cases. But what we are seeing is, as I mentioned, there's interest in doing more advanced routing for scenarios like the Canary deployments, doing things like circuit breaking. These are things that aren't necessarily done all that easily with with the Nginx ingress controller. And so you might want to take a look at things like Istio, which is using a custom ingress. Well, it's using an ingress controller that was created by folks from Lyft. It's based on a project called Envoy, and it provides a lot of power in terms of in advanced scenarios like that. So it's an area that I find very interesting, and I might do a follow-up that shows how something like Istio works in a scenario like this. I need agents in an on-prem VMware because DC because most of our build farm and masters will be in AWS. I will have Tectonic in both locations. What tools help mitigate the overhead of the multiple clusters? The agents in VMware DC will not be reachable from off-network. Can the on-prem agents pull for jobs from the AWS master? All right, that is a really big question. So let me try to break it down. So what tools does Tectonic offer to help with managing the overhead of multiple clusters? Let me start there. So one of the things that we're doing is providing a single pane of glass to manage multiple clusters. So a lot of big organizations, they will have multiple clusters, very similar to what you described, where they've got some stuff on-prem, they've got some stuff in the cloud, maybe they have some stuff spread across multiple clouds, but they want a single pane of glass to manage the cluster. They want to be able to manage things like RBAC in a centralized way. So that's not something we have today within Tectonic, but it's something that we will have very soon in an upcoming release. So it's one of our very active areas on our roadmap that we're investing in. Now, how do we access, so agents in VMware data center will not be reachable from off-network. Can the on-prem agents pull for jobs from the AWS master? That's a good question. To be perfectly honest, I'm not, this is more of a Jenkins question, I think, because the question is are the Jenkins agents polling? Are they polling? Yeah. So to be honest, I have to think about that one a little bit more. And if you want, you can get a hold of me in any of these ways that you see on the screen here, and maybe we could just have like a deeper conversation on it. But yeah, it's one that I have to think about in a little more detail. What else? So between environment deployments, can you run smoke test workflow? Yeah, absolutely. So again, this comes down to how much you've orchestrated within your Jenkins pipeline. So mine was really simple, but with the Jenkins file and Jenkins pipeline, you can orchestrate all sorts of different tests. So like you could have it run functional tests, for instance. So maybe what you do is you have a stage where you've deployed to your staging environment, or you've deployed to some testing namespace, for instance. One of the conversations that we often have with customers is how do you define an environment within Kubernetes? And a common pattern there is it becomes a namespace. And so you might have like a test namespace that you deploy your application to as a stage in your pipeline, and then you kick off some functional tests. And that, the kicking off of a functional test becomes another stage. Now, where I had that pause where I basically do a manual verification. Ideally, as much of that pipeline is as automated as possible. So you try to automate as much of that verification as far to the right of that pipeline as possible. And so if you have all those automated tests in place, then you could definitely have that as a step inside of your workflow. And if they pass, then you can have it automatically proceed to the next step, or maybe automatically proceed to deploying to the next environment, or deploying all the way up to production if you have enough confidence in your automation and verification and your alerting and monitoring to be able to do that. But I find a big inhibitor, one of the biggest challenges really to being able to fully automate out to production really becomes just having all of the automated verifications and the confidence in your ability to respond if there is a problem to be able to do that. Is the UI in Tectonic for Helm charts that user can install a chart? So that's a good question. That's more of again, part of what we're working towards is this providing a catalog for services. We call these open cloud services, and so I can't get into too much of the details in terms of how it's implemented, but the idea is that as a user, you'll be able to go in, and if you want to provision Prometheus, you can, as a development team, you can provision an instance of Prometheus. We have open cloud services coming out for Vault as well. So if you want a way to manage your secrets and your tokens and your certificates in a very secure way through our catalog, you can provision a version, an instance of Vault, and it's fully automated, providing a managed-like experience for all of those services. This question, does CoreOS use Jenkins internally? That's a good question as well. Yes, we do. As you can imagine, our use of Jenkins is a little different, and so we're running every one of our internal systems is that we're running in CoreOS is running on Tectonic, and so that includes things like Jira, for instance. We recently migrated all of our Jira environment into containerized it and running it on top of Tectonic internally. But what's unique about our use of Jenkins is that we're actually deploying Tectonic as part of our Jenkins CI/CD process. And so that one of the things that we're leveraging there is Terraform. So when you install Tectonic, it's using Terraform under the covers, and which makes it really easy to automate the spinning up of entire clusters and destroying of entire clusters. And so that's something that we do as part of our CI/CD process. And when there's a new version, we're spinning up an entire new cluster, deploying applications to it, testing those applications, and then we tear it all down. Let's see, I think that I'm just trying to go through to see if there's anything that I've missed.
Chris, it's Amanda again. We have about a minute left until the webinar ends.
Okay, yeah, so we do have about a minute left, so thanks for the time check. Well, I guess in that case, then we will wrap this up. If you guys have any questions, like I said, feel free to reach me at any of those ways. You could also reach us at info@coreos.com, and we're happy to help answer more questions, and whether it's about Kubernetes or Tectonic specifically, that'd be great. So thank you, everybody. Appreciate the time.